Welcome to a structural design class of one-story building using protastructure. So we continue from where we stopped in our last module. Okay, so in our last module, we were having difficulties of inserting a beam here. So even despite the fact that we have this grid, and yet when we try to insert the beam, it becomes difficult. So when you come across this kind of situation, what you do is that you create a new grid. So we are going to create a new grid line here. So let's stretch this. So we stretch this. So we can now insert our beam. Okay, so we have been able to insert our beam successfully. So let's confirm again from our general arrangement if we have been able to. Okay, before we do that, let's insert this axis. So when you have a curve, so what you do, you go to arc, you click on arc, you click here, you click on the second point. This is my second point. Then you now drag. So I've been able to insert that arc there. Okay, so this is a cantilever. So let's offset this. And here also is a cantilever. Let's confirm it from a drawing. So we have a cantilever here. So this is that cantilever at this point. So we have it at this point. Okay. So we have done with the placement of beams on the layout. So the next thing is for us to define our slab. So to define your slab, you need to first of all carry out some preliminary loading. So to define your slab, you click on slab. Then under general, this is where you impute the slab thickness. So here we are going to use 150 as our slab thickness. So 150 is going to be our slab thickness. So for the concrete cover, we are using 25 mm. You can check my video on how to calculate concrete cover. So how we arrive at this 25. So I have a full training video on it, how to get this 25. Okay, so the next thing you do is to click on load. Now you can see here that the software has calculated the set weight of the slab that we have defined to be 150. So he has calculated the set weight of the slab automatically. So then we need to define the dead load, the imposed load. Okay, so for us to define the dead and imposed load, you need to have a template that you have already done some preliminary computation of the load. And this load will depend on the intended use of the structure. So this is a typical template, solid slab design template to Hero Code 2. This is where we do the slab computation, and this is the template that we use to design our slab. We don't use Prota. We only use Prota to run the analysis in order for us to transfer load from slab to beams. But when it comes to the actual slab design, we use this template to do our design. So first and foremost, you have to define the intended use of the structure. So this very building is a residential building. Now this is very important because if you don't define the intended use of the structure, you might not really know the imposed load that you are going to use. So the imposed load for residential building is quite different from imposed load for commercial building. Imposed load for commercial building is different from imposed load for church, museum, library, and so on and so forth. So you have to establish that. So so we have to establish that, and this is shown in Hero Code 1, Table 6, 6.6.1 and 6.2. Table 6.1 tell you the 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 categories of imposed load, while Table 6.2 give you the magnitude of each of those load intended imposed load that have been defined in Table 6.1. So we will see that in a couple of minutes. So here we have to define the design life of structure. Now, based on this definition that our building is a residential, so we have to also define the design life of the structure. So this is in Hero Code 1. So let's quickly look at the code. So I like doing my design using code. Okay. So this is Hero Code 0, basic of structure, basic of structural design. So let me get this. Okay. So here, design working life. The design working life should be specified. Now note, indicative categories are given in Table 2.1. The value given in Table 2.1 may also be used for determining time-dependent performance, fatigue-related calculation. So you can see this in Annex A. This is the indicative design working life. So our own falls under category 4, which is building structure and other common structures. So this is where we adopt the indicative design working life of the structure in years. So this is where we have the 50 that we use here. So we move straight to the intended use of the structure. So I will drop this template on the platform so that you can take time and go through it. I might not really have time to explain this, but I've already explained this in my previous lesson, so you can go through it. Okay, so the intended use of the structure residential. So this is captured in action on structure. Hero Code 0, action on structure. So under Tab 6.1, categories of use. I said that this one give a description of the categories of use. So we have category A, we have category B, we have C, and then we have D. Then C is subdivided into C1, C2, C3, C4, C5. Then we also have category D, which is also subdivided into D1 and D2. So let's look at where our own building fall into. So we have category A, specific use, area of domestic and residential activity. So you see that it has been clearly defined here that category A has to do with domestic and residential activity. So here we have room in residential building and houses, the room and ward in hospital, and hospital, bed in hotel and hostel, kitchen and toilet. So we have gotten this. So our intended use falls under category A. So let's move to 6.2. So where we can pick the magnitude of that imposed load. So here we have imposed load on floors, balcony, and stay in building. So we have category A, we have the floor. So the floor ranges from 1.5 to 2.0. Then we have the stay 2.0 to 4. Then we have the balcony 2.5 to 4.0. Okay, so for the floor, we are going to use between 1.5 to 2.0. So I think let's go for the maximum 2.0. So when we will be designing the staircase, what we are going to use will be that of the the this other one, which is between 2.0 to 4.0. Then the balcony, we are going to use 2.5 to 4.0. So when we are designing balcony, I have to go back and put a new imposed load. So let's apply that now. So let's apply it now. So the imposed load will become 2.0. So 2.0. Okay, so let's quickly do the loading now. So this is where we have our loading. So we have here design data, bar size used. This is assumed bar size. Then we have the characteristics cylinder strength. Then we have the characteristics yield strength, steel strength. Then density of concrete, we are using 25. So the safe weight has been calculated already. Then we have the 50 mm screening, 1.0 kN per meter square. Then we have the finishing and rendering, 0.6. Now I've given a detail on how we arrive at this 0.6. So this is the detail on how we arrive at that, which is computation of mortar finishes. So we have the density of mortar to be 23. Then we are using plastering of thickness 13 mm. So when you convert that to meter, you have 0.13 meter. Then finishes on one side. So when you compute this, simply multiply the density by the thickness of the mortar, the plastering. So this will give you 0.3. So the finish is going to be on both sides of the wall. That's why we multiply these two by this to give us 0.59, which is approximately 0.6. Okay, so partition allowance to wall load. So we have the unit weight of 225 blocks to be 2.87. So when you add up everything, you have 8.222. Now this is on factor load, meaning that we have not applied factor of safety to it. The reason why we don't want to apply factor of safety to this load is because when you impute this load in the software, when the software is running the analysis, you have to check the aspect of load combination. So there is a provision for load combination in the software. So that is why we don't use factor load when we are imputing load into the software. Rather, we use on factor load. So here is now the load computation for protastructure. We have said here it is on factor load. So this one has been calculated already by prota. So so now, since prota is using 25 and 24, so let's use this 24 for us to have the same thing. Okay, so dead load on slab. Now this dead load on slab, this particular load excludes the safe weight. So for you to have this, you simply click on the total minus this one. So this will give you the dead load on the slab. Then the wall load stroke partition. Wall load stroke partition. So how do we get this wall load stroke partition? Wall load stroke partition. So this will give us when you add the unit weight, of 225 blocks plus the finishes on the wall, you have 3.47. Then this 3.47, we multiply it by the height of the wall to give us the wall load stroke partition. Okay, so this for live load. Then we have this as the roof load, which is the roof load is actually 1.5. The roof dead and live load is 1.5 by 1.5. Okay, so we have been able to define the load that we will put on the protastructure. So we go back to protastructure, this is 4.47. So under here we put 4.47. Then under imposed load we put 2.0, 2.0. So now we are good to go. We are good to go. So we place the slab. We place our slab. Okay. Now, so here we have to delete this. So we have to delete this. We have to delete this. So what we will do here is that we are not going to use the beam. So let's go back to this. So we go back to this. So here we are not going to use beam region, but let's look at axis region. No, let's not use axis region. Let's look at this. No. Let's pick a point. So we go back. Let's right click, go to this. Okay, we can actually use axis region. No. So let's delete this out. Let's delete this out. So let's go back again. Let me go back and define the slab again because I want to use a different live load at that point. So 150 under the load I have okay, so the imposed load, okay, so we still have 4.47. The imposed load for this will now become, so we go back here. This is balcony 2.5, so we can pick and use 2.5 and use 2.5 as an imposed load. So we come to this point. Let me check. No, that one is not going to work there. axis. That one is not going to work. So let's pick point. So let me pick this point and also pick this point. Then pick this point. Okay. So we can also pick this point. Okay, so let's go back again. Let's go back again and check okay. Let's do something here. Let's define this beam. Let me look for a way and define this beam. No. So let's come to okay, so we have to look for another way to insert this slab. So to insert this slab, let us define our beam at this point. Let's define our beam. So let me click on the beam. So we click on our beam, go to property. So from here you click on curve beam, insert curve beam. I will click on that. Then come here, come to this point. No. So let's click on this beam. 225 by 450. Then we click on curve beam. I'll click here, come to this point, then drag the beam to this point. So fine. So we have done that. So the next thing is for us to insert the slab now. So we click on this, change this to beam region. So that is perfect. So we can now remove this. We can remove this. So you now see that we have been able to insert that slab at that point. Okay. We have been able to insert that slab at that point. So the next thing is for us to insert our cantilever slab. So let's look at where we have the cantilever. So we have our cantilever here. We have our cantilever at this point. We have already extended this block. So this one is no longer a cantilever, but it's no longer a cantilever, but let's still insert it as a cantilever. So we pick it from here to here. We have 713. Then we click on this. So this will give what 1838. So let's start with this. So we go back. This is where we are at this point. So you go back to slab. Under slab, you click on this, come to this type 12. So you define this as your 150. Define this. So the concrete cover still remain the same. Then under load you still have your 4.47 because it is the same uniform distributed load that will run extend to that point. So the imposed load is still 2.0. Okay, so we click here. Oh, sorry, we need to put the cantilever length. So the cantilever length here, so let's use 173. We can always adjust. So we click here, so we can always adjust this. So let's adjust this to 600, then we update. Okay, so for this other one, we change this. Okay, we have to escape first. Please, we need to go back to this and impute the wall load, impute the cantilever load on it. So they call this parapet. So 10.41. Remember that we have already calculated this here, 10.41. This is actually the wall and partition load that will be on that cantilever. So we have to impute it. When you click on it, you update and it will show a green line, meaning that that load has been imputed there. Okay, so we go back again to slab. Do the same thing. We come here. Under general, we have 150. Then under load, we have 4.47. Then impose 2.0. Then we go to the cantilever 1838. So let's confirm it from our drawing. 1838, fine. 1838. Then we will also have the same parapet load on it. So we click here and we click here. Okay, so as you can see that it is higher than this. This thing flush together, so we can go back and make some adjustment. So let's click on the cantilever length, so we can check 178. Then we update. Okay, so we need to reduce more. 1750. Okay, we still need to adjust a little. Still need to adjust again. Still need to adjust again. So you adjust it gradually until you get, okay, that is too much. So we can add 5 to it. Fine, that is perfect. That is perfect. So you update and you close. Okay, so we look for another cantilever. Okay, so this is another cantilever that we want to insert now. So let's look at this. So this will be 600 also, from the edge to this 600. So we go back, running from here to here. So we come here click on modeling, click on slab. This is type 12. So the load are still the same. Then the cantilever length. So this will now become 600. So we come to this. Let's click here, then drop, then click here, then drop. Okay, we close that. So let's insert this. So for us to insert this cantilever, we have to then I think this is already there. Okay, fine. Okay, so we go back to slab. So we change this to H, to type 12. Then we input 150 again. You can as well do it this way. You can just click on this, then go to property, then you click here, you click here, so we click here, you cannot find a common axis. Okay, so let's check out what is happening. Can't find a common axis. Okay, so let's go back, right click, go to property, click here, so come here, okay, so let's use the same method that we did. Let's see how we can define this. Let's define this afresh and see how this will work for us. So we also come here and define this. Let's just define this. Stretch this so that we can have a common axis. Okay, let's see if it will function. So we click here, we right click on property, then click here, then okay, I know why we are having that problem. I know why we are having the problem. So what we are going to do now is that this is what we are going to do. So let's just this okay, let's click here, then we come to this point. It's still giving us issue. Okay, so we can ignore this. This will not really be an issue, so we can ignore this. So let's stop the video here so it will not be too long. So see you in our next module.